Today we are going to learn about critical path analysis. For that we have to answer certain project timing questions like how long will the entire project take to complete, which activities determine the total project time. If we say here there are a total of 6 activities, A1, A2, A3, A4, A5, A6, and each activity has a precedent time or a precedent value, so which activities must come before that activity, and each one has got its duration. So what we need to do is that we use a simple box to plot the activity description and the numbers. So here we have the box. Now we plot these activities here. So what we do here is that on the top left hand corner of this box, we start plotting by early start, then early finish, late finish, and late start. And here we will get the float after we complete this diagram. So we plot this into these boxes. So there are a total of 6 boxes and each activity has to be plotted, and we'll do a forward pass and a backward pass using the table and the numbers given there. Now the rule is that the first activity will always start with a 0. So your start time is actually 0. So A1 will have a 0 time duration, and A1's duration is 2 days. So we add this 0 plus 2 is 2, and we take this forward here and we take this forward here. So this 2 comes here and this 2 comes here. Now A2's activity duration is also 2, so this 2 plus 2 is 4, so we take this 4 forward, and A4's duration is 4, so we add 4 plus 4 8, and we do the same for A3 and A5. This is arranged in this way because of the preceding order. So A3's duration is 1, so we add 2 plus 1 3, and we take this 3 forward, and A5's duration is 2, so we add 3 plus 2 5. Now we have 5 here and 8 here, and we have to take forward one number to complete. Now the rule is we always take the higher number or higher value, so we take 8 here, and the duration of A6 is 2, so it's total of 10. So by doing this forward pass, now we know that the total duration of this project would be 10 days, but we need to know which other activities determine the total project time and then find out the critical path. So we do a backward pass. To do a backward pass, we bring this 10 down, which is our late finish, and we subtract it. When we went forward, we added it. When we go backward, we subtract it. So 10 minus 2 is 8, and then we take this 8 here and we take this 8 here, and then we subtract 8 minus 2, 6. So we take this 6 here, 6 minus 1, 5. And same thing we do here, 8 minus 4, 4. We take this 4 here, 4 minus 2, 2. Now While doing the backward pass, now two activities are merging into one activity, so we take the lower value as against the higher value when we were doing the forward pass. So from 5 and 2, 2 is a lower, so we take this 2 here, and 2 minus 2 is 0. Now it's very easy to know the critical path. Wherever the float is 0, that will be the critical path. So if you see 8 minus 8 is 0, 6 minus 3 is 3, 5 minus 2 is 3. So here we are not getting 0, so this is not the critical path. So what we are getting here, 8 minus 4, we got 4 here, so 4 minus 4 is 0, 2 minus 2 0, and 0 minus 0 0. So we can see that this is our critical path, which is A1, A2, A4 and A6. So we can say that the critical path that we get here is A1 plus A2 plus A4 plus 6 is equal to 10. So that's our critical path. Now further, we can reduce the timing of this project by crashing the activities on the critical path and increasing the cost by doing so. That we will study in the next lesson. So basically, we have learned today how we can calculate the forward pass and backward pass and determine the critical path, which determines the total project time.